Hello friends, welcome to my YouTube channel Make Maharashtra, which provides you educational videos. Now we'll start with the numerical of the worm gear design. These are the basic important numericals which will be asked in the examination. So previously I solved one numerical, you can check the video, take a reference. Now this will be the second example which I think it is important. So the given data is given directly in the statement. I'll read and tell you the steps how to solve. Now you can see worm gear drive having pitch circle, that is PCD, 48 mm pitch circle diameter of the worm, 192 axial pitch given, pressure angle 20 degree, lead of worm, lead directly given, that is ZW. Then effective width of the worm gear teeth is given, worm speed NW, permissible bending stress of the worm gear sigma BG, worm gear wear factor, that is K, coefficient of friction mu, overall heat transfer H, overall heat transfer coefficient with fan and without fan. This is very important. This is the important one in this numerical. So I'll explain with fan and without fan what, but just check the value. With fan 15.2 plus 8.25 into 10 raised to minus 3 into NW, that is RPM of worm, watt per meter square degree centigrade. Effective area they have mentioned something 9 into 10 raised to minus 3 into A raised to 1.88. Now A is nothing but you will have to take center distance, means dW by dg divided by 2, that is. So frictional losses in the bearing, that is 4.5% of the total input power. So this we need to consider frictional loss while calculating the power. Determine dimension of the worm gear, input power, dimension of the worm gear, input power, you can see here, input power rating, that is PI, temperature rise in lubricating oil without fan. So without fan terminology we'll have to use from the given data. And is fan is necessary, comment, so we need to give the comment. Lewis factor they have given, that value we need to take. KV factor they have given. Efficiency generally we have taken tan of lambda divided by tan of IV plus lambda, but here they have mentioned the efficiency range, so this efficiency will have to take as it is. Clear? Solving the numerical. Now I'll tell you, the first of all they have given dW, dg, axial pitch directly given, pressure angle, lead, face width NW, sigma BG, K wear factor, coefficient of friction, overall heat transfer coefficient. And they are asking for dimension of the worm gear. Just calculate input power, temperature rise, fan necessary or not. So one by one we'll go. Dimension of the worm gear, these are called as a terminology. So one by one, lead is equal to generally PA into ZW. So PA is given, lead is given, so we'll get number of start ZW1. So PA is nothing but pi into M. So PA known, so from this we'll get the module, 6 module. Then dW, diameter of worm, M into Q, M and Q is not known, so Q will get from this 8. So next will be the dg, diameter of the gear, M into ZG. So dg is known, M is known, ZG is not known, will get the value of gear ZG. These are the basic terminology. Now from the gear ratio we can say NW by NG is equal to ZG by ZW. Unknown is NG, RPM of gear. This required for calculating pitch line velocity 109. So tan of lambda, through which we can calculate lambda is 7.125 degree. Clear? So these are the basic things. For the designation I will have to keep the values here, that is center distance dW we have calculated here, the value of dW 48, correct, and dg 192. So I will have to put 148 plus 192 divided by 2. This will be the center distance. Why center distance is required? Because in given data they have given A is equal to CD, center distance. So in that we'll have to use this value. Now length of worm, pi into M in bracket 4.5 plus ZG by 50. So put the value, we'll get the value of LW, and of course the angle is less than 15 degree. So addendum, dedendum in terms of module, and normal module we have calculated. So these are first part we have covered, that is dimension of the worm. Now move toward the input power. Now step number 2, to calculate input power we must know the things, basic things such as beam strength. I will have to use sigma B into module into Lewis factor into cos of lambda. Why? We can calculate Lewis factor 0.3965. Then beam strength, just put the values and beam strength will be 7648. Wear strength DGBK, direct wear strength 5736 directly get. So we'll have to check. So in this what happened, the beam strength is strengthened, that's why wear strength is weaker. So in safety factor we will have to take wear strength. Next step, step number 3, effective load. We can calculate K into FGT by KV. So VG, why required? Pitch line velocity to calculate velocity. So VG is equal to pi dg ng by 60. So one by one we have added dg 192, ng 109. So through that VG is equal to 1.09 meter per second. VG, pitch line velocity of gear. Therefore KV value 6 by 6 plus V, it gives 0.845. Correct. All this value will have to put in this equation. You will get F effective in terms of FGT, that is 1.18 FGT. Clear? This will be the step number 3. Now compare with the factor of safety factor, that is FW is equal to FOS into F effective. FWI because it was weaker, so through which we'll get the maximum tangential force on the gear 4848.6 Newton. This much part is okay, you know it, previous numerical also we have seen this. Here is an important one. They have directly given the efficiency, and earlier we have calculated efficiency output by input and by using tan lambda equation. Now here FGT known, we'll have to calculate output power, that is FGT into V. So it will gives you 4848.68 into 1.0. So value would be 5331.1 watt. This is for output power. Efficiency in that they have mentioned alpha is nothing but you will have to take pressure angle, and here they have mentioned gamma will have to take lambda lead angle. So that is very important, we need to check, because most of time what happens, the student by reading the numerical, see this efficiency, students are directly saying data is wrong, something is wrong, the mark will get and all that. No, so we need to take care of it. So here we will have to consider alpha is nothing but pressure angle 20 degree, lambda is nothing but gamma. So just put the value, all the value here, will get the efficiency, and that efficiency is around 82% from this to calculate input power. Therefore input power is PO by PI, output power by input. Therefore output power we know, given data in that they have given, so through which we'll get the input power is 6.4 kilowatt. This is for efficiency condition. Now we are using in thermal effect, temperature condition, because these conditions are also given. Now effective area they have given 9 into 5 into A raised to, A is nothing but center distance. So center distance we have calculated, see here, we have calculated here center distance 120. So same value I will have to kept here 120. So through which area will be 0.7 meter square. The power loss due to friction, as I told you in numerical, power loss means heat generation. So that will be the value PF is equal to PI minus PO, actually in terms of efficiency. But here they have mentioned the 4.5%, see 4.5% of total input frictional losses they have mentioned. So that now losses will have to consider. Therefore equation is coming like this, PF is equal to PI minus PO. Instead of efficiency we'll have to add frictional losses, that is 4.5% of input power. So input power 6.4 kilowatt, so I have written over here. Now output power known, plus this 4.5% means 4.5 divided by 100, it is 0.045 into input power 6.848 kilowatt. So it is in watt, we'll have to write. So through which power lost 1447.9 watt will get. Clear? Is that clear? Power lost means what? Heat generation. Here they have mentioned. So same value will be there. Okay. See the steps, procedure, very important. particularly from this step number 5. Next, now they are asking whether temperature fan is required for the temperature or not. So first of all, one by one, lubricating oil consider with the fan. So fan condition they have given. See, again I am giving the inputs from the data. See, with fan, did you get this value? Did you see this value? 15.2, that value, and without fan 60, correct? So first of all, take with fan. So value is this, they have given, nothing to do. So just kept as it is. Instead of that, they have mentioned NW we have calculated 3500. So by putting this overall heat transfer, 44 point something is for with fan, correct? And for that heat dissipation, HA delta T, H is known, we have calculated here. Area also we have calculated, delta T is not known right now, therefore heat dissipation is in terms of delta T. Now we'll have to compare heat generation and heat dissipation. Heat generation is nothing but PF, power lost. So power lost we have calculated 1447.91 and heat dissipation 32.15. So just add it, we'll get the delta T, which is the unknown, is 45 degree. So this will be the value with fan. It means what? Temperature with fan of the system is 45 degree. Clear? Temperature rise will be 45 degree with fan. Now we'll check without fan. See, without fan, what happened? Overall heat transfer coefficient for without fan 16 they have given. So heat dissipation is equal to HA delta T, H known, area calculated, delta T not known. So compare the power lost, that is heat generation, with respect to heat dissipation. So delta T without fan is 124 degree centigrade. So it means that if the value of temperature without fan, temperature of lubricating oil without fan is more than 50 degree, listen, more than 50 degree, there should required fan to cool, otherwise teeths are worn out, correct? Value of lubricating oil without fan is more than 50 degree, the fan should be used for effective dissipation of heat. Clear? So answer is fan should be used. So such kind of the numerical we need to solve like this way. Again I'll explain, revise it. So the given data you need to read it. Terminology, step number 1, dimensions. Step number 2 will be beam strength. Next will be the wear strength, checking of weaker part, that is effective load, add the values, and with respect to factor of safety or safety factor, tangential force will get. Now through the output power and efficiency as per their given data, efficiency is calculated, and through which input power is 6 point something. Now they have given the area, specialized area for lubricating oil. So for that lubricating oil we need to calculate power lost plus 4.5 is important, that we need to add, that is frictional loss. So after adding this we'll get the power lost, which is equal to heat generation. So heat generation. Next will be the with fan and without fan we'll have to check. Now with fan temperature of lubricating oil is, with fan 15 plus something is given. So just add it and compare with the HD and heat dissipation and heat generation, will get 45 degree. Okay, without fan, sorry, with fan is this much, that is sufficient. Now if without fan temperature of lubricating oil, that overall heat transfer is given without fan and HA delta T, and compare the dissipation, heat dissipation and heat generation, will get 124 degree centigrade, which is more than 50 degree. I told you, when the value of temperature rise in the lubricating oil without fan is more than 50 degree, there should be required fan, correct, for effective dissipation. So this will be the numerical. Beyond this they will not ask any numerical. Whatever I have covered, that numericals are more than sufficient. But dear students, the practice from your side is very important, so do the practice. If any query, ask me in the comment. Now this will be your next homework. So please take a screenshot of this numerical and try to solve carefully, and after solving make a PDF and upload it on a Google Classroom. Thank you.